right, so now we're looking at shapes that are not directly on top of the axis we're rotating around. So if I look at this parabola, 5 minus x squared, and bound it by the line y equals 1. If I take this and rotate it about the x-axis, well, this region here, from y equals 1 to y equals -1, when I rotate around, I'm going to end up not ever covering this space here. So when we rotate this around, I'm going to end up with this shape that has a hole through it. So it would be like I'm creating, if I look at my cross sections, well, yeah, something with a hole in it. So wrapping this around, and I don't know how to draw this in such a way that you can see it, and I'm not sure that I can, well, let me see if I can make it in GeoGebra. So now we've got our f of x is going to be from, what did we have there? At 1, I would have, so at when y equals 1, that implies that this is 4, so x is 2. So from -2 to 2, and we had 5 minus x squared. Okay. If I take this and spin it around, and right now we're going around the x-axis, so I can see that I've created kind of like a donut. So there's my picture. That's pretty good. So if I want to come up with the volume of this thing, let me come back over here and add this. So that's very large. Okay. So if I want to calculate this volume, I'm going to do the same sort of idea. I'm going to make myself a bunch of disks as I cut along my x-axis. And if I think about each of these disks, well, here's my profile, so I'm starting this way. So from the center up to the top, that's going to be my y sub k value. And then inside, I've got this circle that has a constant radius of 1. So if I want the total volume, I'm going to take the whole cylinder. So I'll have pi r squared. My width is going to be my dx. So I'm looking at my donuts coming across this way, each little slice across my x-axis, minus pi r squared dx to get the volume of this cylinder. So if I take out the cylinder on the inside, that height is, oh, sorry, my delta x. I'm not integrating yet. So that would still be delta x. So that would be for one cylinder. Of course, just like we did last time, we're going to let our disks tend to infinity and rewrite it as an integral. So I'm going to have the integral from a to b of pi y squared dx. So remember, y is my function in terms of x, minus pi, and now I'm going to take out whatever the second function is. So in this case, it was a constant of 1, but it might be a second constant, or a second function, defined by g of x. So I would need whatever that radius is. So here, I've got my first radius, the one that's bigger, and we've said here that f of x is greater than g of x. So we would have f of x squared minus pi g of x squared dx. I have to square and then subtract. It does not work if I try to do my subtraction and then square. I have to find the total volume and subtract the inner volume. So square, then subtract. This is very, very important. All right, so let's go ahead and find that volume. I'm going to have my integral from -2 to 2. I can put my pi in front. R squared. I could save my dx until the very end, minus. So my next function is just 1 squared. And now I can have my dx. All right, so simplifying, pi, -2 to 2. I'm going to have 25 minus 1, so that's going to be 24, minus 10x squared plus x to the 4th. And now I can integrate 24x minus 10/3 x cubed plus 1/5 x to the 5th, evaluated from -2 to 2. And I'll let you go ahead and do that evaluation because that's not the important part of this learning.